for nice, cool summer. B, 2014, at Gatorville. My name is Horvath. I expect you all know that. I've had the pleasure of lecturing this course 40, 50 times, at least, over the past many years. And if I have my way, I will lecture it another 40 or 50 times over the past many years to come. Regardless of the fact that yesterday was my birthday, I'll accept that because my daughter called me up to give me a belated happy birthday today. How old did I become yesterday? 17 plus? $17 plus 55. 72 yesterday. And I love it. I wouldn't trade teaching this course for anything.
That's a nice cruise to the Caribbean.
You have the pleasure of looking at a very fortunate person. Because in life I have been able to come to do that which I love to do more than anything. And that's have the opportunity to share with all you wonderful folks some knowledge and understanding of the great science known as chemistry. The physics of molecules, as I choose to define it as simply as possible, given that physics underlies all science. I expect by now you've learned that if you wish to be a botanist or entomologist or any kind of ist, like a chemist, you have to know some physics. You cannot escape from it. Because physics is the science that provides the understanding. Now, chemistry is such a huge subdiscipline of physics that it's too large to be taught as part of a physics class. And there's too much to be learned by someone who chooses to major in physics. Unless, of course, you have a most powerful, all-encompassing mind which can allow you to major in physics and chemistry simultaneously. Whew! I'd like to be that good. So, that gives you an opening shot regarding what I think about the importance of this gathering, where we will focus on understanding. That's where it's at. When you can explain, you have useful knowledge. When all you can do is repeat after me, you're ready to go play Jeopardy. And I have no use for going to play Jeopardy. I mean that seriously. When people earn great sums of money without demonstrating whatsoever any degree of understanding, I don't like that. I don't think that's reasonable. Understanding is where it's at. And you'll assuredly find that out when you begin to deal with these most wonderful adventures known as quizzes and exams. On no occasion will I ever ask a question that invites you to say something back to me as a piece of factual information which I've shared with you. Never. Understanding all the time, that's what I go for. And that's what the questions are aimed to find out. Find out if you can demonstrate understanding. Because that's where it's at. With understanding, you learn. And with learning, you appreciate. And with good fortune, and if you've got the right attitude, this will develop within you an intellectual thirst and passion to go on and learn more. Ah. You see, I believe sincerely the most important thing you can do in life is to learn. It gives you what you need to take on any challenge, if you're going to be able to take on the challenge at all. Learning, that's where it's at. Now then, some practical stuff. First, how many of you are registered for Monday, Wednesday, period 1 to 46L, but did not attend this morning? Because the enrollment for that gathering was way short of the nose count. So if you're in this category of folks, you're already behind. If you're in this category of folks, you contact the laboratory manager directly, provide a brief explanation of why you didn't attend, and indicate that you will never again miss 46L, and you'll be given the opportunity, with good fortune, to schedule a makeup for the missed session. Normally, we never start laboratory in the first week of a term. But for some reason I do not understand, this course is offered during this 6-week scrunch time. It shouldn't be like that. It should be taught strictly on a C-term basis. But I don't make these kind of rules. The administration makes these kind of decisions. My decisions lie within the realm of deciding what goes on in the course. But since the administration opted for B-term 2046 and no C-term 2046, and since I'm the one who does 2046 every summer, well, here I am. Now then, for those of you who still have to check into laboratory, which is tomorrow for the Thursday folks, please note this sentence, which is in this short paragraph beginning the term. Read carefully. To get started properly at 46L, answer question 1.1 on page 1-11 in assignment 1 before you arrive for check-in. Your laboratory instructor, your TA, will check your response to this question while you are checking in. All entries in the lab book are to be made in indelible ink. No erasing permitted. This is a book of record. And when your response to this question is acceptable, which will serve to indicate that you know how to make solutions by dilution correctly, which presumably you learned in 45L. So I'll ask right now, how many of you did not take 45L here? Okay. Well, you may be somewhat, but not really, in a bit of difficulty at the start. But if you've come to us with a reasonable chemistry background, I expect you know how to make solutions by dilution. And we are not in position, because of the large number of you folks, when, for example, for an experiment you need a few milliliters of a dilute solution, there we go, to place huge quantities of these solutions in large bottles on the side shelf. So instead, we place adequate quantities of concentrated solutions, the likes of which you need, and invites you to make dilute solutions in the quantities required for your experiments. So the main purpose of assignment 1, in addition to starting to learn about the fundamentals of acid-base equilibrium, is to be sure you know how to make solutions correctly by dilution. That's why your response to this question 1.1 is so important. Your laboratory instructor will be glad to help you in responding to this question if you're not quite certain of all the required details, which you are to describe in writing in response to this question. Other than that, since you've all had laboratory before 46L, I expect you know how to conduct your affairs in laboratory. Department-approved safety glasses to be worn by all. Goggles are all right, but they're a lot less comfortable than these UVEX safety glasses. These are light, convenient, and inexpensive. Long, loose-fitting pants for both males and females, the likes of which are described on the first page of the syllabus for laboratory. No long, flowing hair. Hair is very flammable, and you'll be using open burner flame quite regularly in the laboratory for your laboratory work. And indeed, the laboratory manual itself in your possession. No lab book. You're not permitted to check in. If you're not permitted to check in, ever so obviously, you're behind. Other than that, policies and politics by which the laboratory course is conducted is explained in detail in the syllabus. If you've not yet read it completely and carefully, do so. And if after having done so you have questions, ask your laboratory instructor. Now, lecture. First and foremost, this is the text for this class. It's called Chem Notes 2. I wrote it. It's getting out of date. My apologies for such. But rewriting takes a long time, and I haven't had a chance to proceed very far as yet with the rewriting process. But I'll get to it as soon as I can, I guarantee. One more reason why your attendance at all classes is so very important, because the gaps in these notes will be dealt with by in-class presentation. Any new material not yet covered by these notes will be presented by way of in-class presentation. Available at any of the local bookstores. Why do I want you to have these notes? So that when we are in class, as we are now, we can devote our time to understanding the material that's contained in these notes, as opposed to your spending time to record notes. Now you have the notes. If you attend class regularly, as I expect you to, you'll always know where we are. You'll always know what you should read before attending class, and recognize that this note package is to be with you at each and every class, Thursday's discussion gathering included. Because when we deal with questions and problems and the like that are contained in the notes, I'm not going to take time to write that on the board, because I will expect you have it in your possession by having the notes with you. Now, I expect right now that some of you do not yet have this. I understand that. I'm sympathetic with that. But come tomorrow, I will be no longer sympathetic with that. By tomorrow, I expect everybody to have these notes. Comments on the syllabus for lecture. Sections. The Thursday discussion sections, which meet at 8 a.m., will be merged. You don't have to change any time. You don't have to change any registration status for those of you who have period 1 discussion. I will tell you which room that everybody is to attend before we get together for first discussion gathering this Thursday. Same applies to period 2. Period 2 discussion gatherings are merged. There's not enough folks enrolled in the 2 scheduled period 1 or period 2 discussion classes to run 2 separate discussion gatherings. We got 11 in one and 13 in the other, something like that. So we'll bring them all together, put them in one room, and have 23, 24 cozy, comfortable people. Okay. Now, for the 4, 8, 7, 8, 8, 9, 4B11, 4B12, and 4B15, pardon me, where this registrar dreamed up these section numbers, I'll never know. Crazy section numbers, okay. There will again be section merging. Now here we have 4, 8, 7, 8, and 8, 9. Pardon me, wait, I'm saying this incorrectly. For period 1, let's get back to this, say it correctly. For period 1, we're going to take the 2 sections, 4A, 1, 9, and 3, 2, and they will become one section. And then for period 2, 4A, 4, 6, and 4, 7, they will become one section. Okay? You won't have to change any time. We'll tell you before Thursday which room to go to. And then for the 4A, 5, 1, 6, 4, and 4B, 1, 4, those are 3 sections. Second line under section 4A, 5, 1, 4A, 6, 4, 4B, 1, 4. There's 3 sections. Those will become 2 sections. But again, you will not have to change any time. We'll tell you which room to go to. And I will tell you by email, for those in those sections, which section to actually attend. That only means which room to go to. You don't have to change any time. You don't have to see the registrar. You don't have to do any of that kind of stuff. Now then, carrying on with information in the syllabus. The text is this. I told you that. There is a remark I've made there about the Silverberg text. I know of no existing general chemistry text which does any kind of a reasonable job to support what I attempt to get across in this gathering. I don't use any general chemistry text. I use my notes. That's it. Discussion section, we've already made mention about that. Prerequisites. If you think your background is inadequate, then see me as soon as possible so I can, with hope, find out if it is inadequate or in fact you have a good chance to carry on with us and be successful. Because I want you all to be successful. That I mean ever so seriously. Course information, we've already made mention of that. The most important statement regarding such that I will present to you at this time is, as I've already stated, you need to be with us all classes, in Thursday included. You need to have Chem Notes 2 with you all the time. And you need to pre-read the stuff in Chem Notes 2 where by class attendance you will know where we're always heading. So you know what to read. That's why in the course schedule I've not placed any dates. Because I don't know where we're going to be on a given date after we get started. We are where we are. I'm not letting any calendar run this operation. Course presentation and material content decides where we are. Cell phone. Regarding cell phones. You see this CPO? Exclam, bottom of the center board. Who can translate CPO? Cell phones off. Now I expect these days everybody has one of these marvelous little devices. I didn't have one until a few years ago I became engaged to become married with a sweetheart little Vietnamese girl who said, "Get a cell phone so I can contact you when I want to contact you." And I said, "Yes, dear." And the next day I had a cell phone. But I do not want that cell phone rattling in here while we are doing business. You know how to turn it off. But if your cell phone does rattle, I have a curative device in the back. It's called an 8-pound sledgehammer. I assure you that after I apply the curative device to your cell phone will never rattle again. We've already talked about the course schedule and your need to be with us at all times. Oh, I did pass by one thing. Up at the top, website Absolutely Chemistry. You'll notice our man in the back, Tu Win, one of our discussion instructors. He's now done this course with me many times. And all classes for this gathering, not discussion classes, that we haven't got a way to do, but all the lecture classes for this gathering will be recorded and will be placed on this website. This provides the opportunity for any of you who wish to review or hear me say the same thing more than once Find out when you in fact take a look at chemistry. You don't. You've been lied to. You've been cheated. You got this nice A on your scorecard. But it doesn't mean anything. It's a false representation of academic achievement. I don't go for that stuff at all. So I have a different way of keeping score. But at the minimum for now, recognize that I keep score by total points, period. There's no curves, there's no statistics, there's no percentages, there's no comparison of what you do to anybody else. Now, Sakai insists on percentages, so I'm telling you right now there's a statement here. Never mind what Sakai says about percentages. That means nothing. As we go along, you just add up your points. And as this syllabus says, we got to make a correction. See where it says to make an A? It's supposed to be 1100 or up. Always there are mistakes in this thing. That's a typo. All the rest are right. I don't know how I missed that one. 1100 or up. 1300 is the base value. But you will find if you add all the points that I make available for you to earn during the term, you can wind up with probably 16, 17, 1800 points. It's not points that I'm concerned about. It's learning chemistry that I'm concerned about. And if you do what I ask you to do, like be with us at all times and be prepared, you'll place yourself in marvelous position to make that A, which I know you all want. More comments on that shortly. Okay, attendance reminder, I told you about that. One last comment regarding the statement at the bottom of the second page of the syllabus. If you have any questions at all about this course and its content, the chemistry we're asking you to learn, don't contact me by email because I'll delete it. Don't contact me by telephone because I will reject the call. See me in person. That's it. Now, one contact regarding this activity that I will allow by email or telephone is for you to tell me when you can see me. That I'll accept. But there will be no discussion of chemistry or course difficulties at all by any mechanism other than face-to-face. That's the way it's got to be. Same goes with you and your discussion instructors. Now then, I think all our discussion instructors are here today. So I want them all to come forward right now so you can take a look at the people who you will be expected to see on an out-of-class basis when you need assistance. And I guarantee many of you on a regular basis will need out-of-class assistance. Come on, discussion instructors, all up here right now. To win, you just stand up in the back. Look around, that's to win. Stand up again. Stand up. Good. Tell them your name so they can hear it.
My name is Tu Win.
All right. Here they are. I will let them speak to you in a loud, bold fashion to introduce themselves. And if they don't present themselves in what I consider to be a sufficiently loud, bold fashion, I'll tell them to do it again. They know it because they know me.
I'm Nathan Richie.
I'm Alyssa Mitchell.
Colin Zach.
Samantha Axelrod. Nick, nice to meet you guys.
Aya De La Rosa.
Take a look at these faces. Because these are the people that you want to see, including me, of course, if and when you need out-of-class assistance for this gathering. Thank you, folks. Now, regarding out-of-class assistance, my available times are stated in the syllabus. And the syllabus also tells you that I know that sometime you might want to see me and your schedule would not allow during scheduled office time. Anytime my office door is unlocked, you're free to walk in. Now, I generally keep the office door closed in the summer because the hall is warm. I don't want the warm air blowing in there. At least not too much warm air. I do like it warm. That's why I came away from Toledo, Ohio in 1967, and I said, to hell with the frozen north. After all, in March 1966 was the first time ever in my life I had had the opportunity to go south of Ohio. When I left Ohio, it was sleeting, cold, miserable, as it usually is in March in Ohio. It was like that all the way till we got to North Georgia. When we got around Macon, south of Atlanta, weather's starting to brighten up. I was with a friend who was invited to come here to UF for graduate school in chemistry. He was a year ahead of me. So one of the reasons of our trip was to drive through Gainesville so that he could take a look at the University of Florida. Well, in driving through Gainesville in March, as many of you, if not all of you already know, it's beautiful. Azaleas are blooming, flowers, the grass is green, the weather is great, people are outside walking around in shorts, and I said, where have I been? And then we had the extra benefit of another friend of mine who was with us on the trip, who had a sister in Fort Lauderdale, who was gone for a week and let us spend 1 week, because that was our spring break from the northern schools. That was our spring break time. So we had the opportunity to spend a week staying at her place on the beach at Fort Lauderdale. I knew then I was coming to Florida. If I had to make a living picking oranges, it was good enough for me. I mean, more than good enough for me. I says, I'm going there. And that's where I came, 1967, when I started my graduate career here at UF. I'm still here. I like it here. Now then, as a matter of practice, to give you a better opportunity to know me and to know what other students like yourselves have thought about me. I always like to read some stories which were written by students just like yourself about me. If you wish to provide me with a written account anonymously of any stories of interest that you've heard about me before coming to this class gathering, I will appreciate such. Write it up, slip it to me. That's how I got these. I've been collecting these for many years now. I've distilled from that collection what I consider to be some of the best. To give you an idea what students think about Horvath. Because I know damn well around this campus some marvelous tales are floating regarding me. I know that. I know that. This is from 08. Horvath's story. 3 stories written by one student. Horvath is ridiculous. Avoid his class at all costs. He's off in his own world, speaks his own language that's nearly impossible to understand. But if you can get into his mind, stay in his class. But for the other 90%, get out. He makes you buy a book of his own notes. That's chem notes. Which are so confusing and don't help you learn chemistry at all. And then the last statement by the same student. If you're looking for an easy A, you're not going to get it. But if you really want to learn this stuff, then take his class. He knows his stuff. He's a genius. His lectures are great. Statement. I try to make the lectures as encapsulating and capturing as they can be, because if I do the very best chemistry presentation that can be, but I do it like this, you're all going to be asleep. I won't stand for that. You might do a lot of things in here, but sleeping ain't one of them. Will teach me everything I need to know. That really is the most false statement of all the stories that I've collected. It's impossible to teach you everything you need to know. It's impossible for anybody to teach you everything you need to know. Furthermore, who's the best teacher you have? Huh? Yourself, by far. Don't forget it. I heard that no one can pass your class. I like this one. 46, spring 09. I had 2 lecture sections. 504 students started, 421 finished. I don't count the ones that drop and go away. Now, of the 421 that finished, 121 A's. That's 29%, which was the highest percentage of all those who took a grade. B plus B plus A, because we didn't have minus grades then, became 253, 60% of the class. If I had in the C's and C pluses, 370, which was 88% of that class which started, made C or better. 29% of which made A. Well, if that means no one can pass, then I don't know what the hell this statement means, no one can pass. I can read a bunch more of that. But I will just wrap that up by saying, at least 60 times. I know I've done this at least 60 times, this class. Only 2 times out of the 60. Only 2 times. This I know is a fact. Has the most common grade that I've written on the registrar's scorecard for those who finish the course been other than A. The most common grade, 58 times out of 60, for those who finish the course, is A. The A is there. You do what I ask you to do, I mean it's there. I heard if you survive the painstaking torture of his class, you are prepared for the hell of putting yourself through medical school. One of the pleasures I've had is writing numbers of recommendations letters for students applying to medical school who have come back to tell me, thanks for getting in. And I said, don't thank me, thank yourself. You just did what I asked you to do. And along the way, they generally tell me that when they took the chemistry part of this MCATs, that was a fish next to what I asked. And I'm sure it is. Look up evil in the dictionary. See Horvath. This man feeds on the dreams of college students, then rips their hearts out, a la Indiana Jones in the Temple of Doom. Steer clear if you value your very existence. Before I attended the first class meeting, people told me that Horvath was tough, rude, and a big jerk. One girl told me that he took a copy of the book she had just bought and threw it across the room. That's a lie. I kicked it across the room. That was a general chemistry text. And I told her, I held up the book and I said, you see this book? I have no use for this damn thing. Its best value is doorstop. So I slammed it to the floor and booted it across the room and managed to kick that door. And also hurt my toe, but that was worth it. The department has asked me to cease and desist from doing that anymore. Phooey on them. He is Satan himself. I heard you eat the souls of little children. I've not heard many stories about you except that you're a very difficult teacher. However, my impression of you during the first class was that you are a crazy version of Willy Wonka, except in love with chemistry rather than candy. Have you thought about moonlighting as an actor? As I said, part of what I do has got to be acting. If I don't make a presentation which keeps you interested, I'm failing. I'm failing, not you. This is a complimentary statement written by a student who told me how terrified she was of my reputation, but wound up staying through the class and thanking me very much because, as a consequence thereof, as she put it, she got into medical school. Again, she got into medical school because of what she did, not what I did. Now, we used to do evaluations on a written in-class basis, which I think is better than what we're doing now. And this was the second side of that evaluation form, where students were asked to write comments about the class in consequence to responding to questions. Question 1 was, what personal qualities or teaching skills did the instructor contribute to the success of the course? Student wrote, absolutely none. He's enthusiastic about chemistry, but that only serves to make me feel more like an idiot. Question number 2, did any qualities or teaching practice of the instructor hinder the success of the course? Student writes, where do I start? He talks down to the class. He has tantrums in every class about chemistry book authors. His tests make you feel like a failure. His bonus quizzes, which is what I used to call the special quizzes, aren't even on Chemistry 2046, but on Chemistry 2210. I don't give a damn, it's chemistry. Because one of my main intentions is to have this course prepare you for classes to come. That means chemistry. That means analytical chemistry. That means organic chemistry. That means physical chemistry. And I like my students to come back to me after they've been through these experiences and have the nerve to tell me, when I took your class, I thought you were a no-good, rotten son of a bitch. But I made A's in those classes, and now I know the value the class was. All right? He's out to get me. Next question. What's your opinion of this course, including printed materials? No one can understand his notes, so you're forced to go to tutoring zone. He scares you away from going to his office because he expects too much. Baloney. Question 4. Add any other comments? I have not yet given a professor a bad rating, but this man is evil. Stay very far away unless you want to chew off all your nails and cry yourself to sleep every night. And now one more of these, my very favorite. Question 1, personal qualities, teaching skills contributed. He knows his stuff better than anyone else on the planet. Question 2, did qualities or teaching practice of the instructor hinder course success? He does not realize that we do not know the material as well as him, so he teaches much far above our level. Question 3, what's your opinion of the course? It's the hardest class I've ever taken. I study well over 10 hours a week, seek outside tutoring assistance, and still I perform poorly. 4, add any other comments. When bad people die and go to hell, they end up in Horvath's chemistry lecture. And so we go. The first topic to be considered in Chem Notes is that of chemical equilibrium. Do you remember any comments being offered you about the establishment of chemical equilibrium by way of your studies of kinetics at the tail end of Chemistry 2045? Remember that? From a kinetic standpoint, when is equilibrium established? From a kinetic standpoint. When is equilibrium established for a reaction system? When? Go ahead.
The rate of the reaction.
Rate, forward reaction for the reaction system is exactly equal to the rate of the reverse reaction for the same reaction system. So even though equilibrium is exclusively and strictly a province of chemical thermodynamics, the origin of equilibrium comes to us from kinetics. A reaction system. Reactants, products. Turn it around. Now the products are the reactants and the reactants are the products. And just about every reaction achieves this condition known as equilibrium. That's why equilibrium is so important. I wrote that up here on the board. Equilibrium is the most stable thermodynamic state in which a reaction system can exist. Therefore, equilibrium is very important. I mean, if just about every reaction can exist and does exist under this condition after it's been conducted for however long it takes to get this rate balance achieved, well then we better know about equilibrium. What are you going to do in 46 laboratory this term? I'll tell you what you're going to do. The standard term for this course, for which this is the lab book, There's qualitative analysis. Even the information book supplied by UF regarding Chemistry 2046 calls it General Chemistry and Qualitative Analysis. I'd be happy if they took that away. Because in the main, what you're going to do in 46 Laboratory is to learn how to deal with, control, and fight the equilibrium condition. Because when a reaction system comes to equilibrium, no further conversion of reactants to products occurs in that system. And if you've got a unique reaction in which in which lead is being converted to gold, you're this brilliant alchemist, and the starting material lead is difficult to come by, even though the value of the gold is far greater. If you spend a lot of money to get the lead and only half the lead that you start with converts to gold, you're going to lose half your starting materials. Why did only half the lead convert to gold? Because after conversion of half the lead to gold, equilibrium took over. You think that the chemical industry, if you're involved in this lead to gold conversion process, might want you to do a better job than 50% conversion if only half the lead becomes gold, 50% conversion? You think the people who are signing your paycheck might want you to figure out a better way to convert lead to gold than 50%? That's the main aspect of 46 Laboratory. To learn about chemistry equilibrium, chemical equilibrium. Exclusively in, as far as we're concerned, water solvent. Do you think chemistry and water solvent's important? Do you think there's chemistry taking place in other solvents which are more important than chemistry and water solvent? Do you realize we live in a water solvent life system? Blood, sweat, tears, rain, streams, rivers, oceans. Hey, if there's any chemistry which is of vast, huge importance, it's chemistry and water solvent. So guess what we're going to pay attention to this term? Chemistry and water solvent. You betcha. Now, statement. For equilibrium to exist, all system components must be present. That means reactants and products. And solute species must be present at constant concentration. In other words, the concentrations are not changing anymore. And or partial pressures for each gas. If there's one or more gases involved in the system, and the system's at equilibrium, you'll find that the system is equilibrium by measuring gas pressures for the component gases of the system to find out that these gas pressures are constant. They're no longer changing. And the system must be dynamic. What kind of system is dynamic? What phases are dynamic? Now, when I ask questions like this, I expect you to respond. You don't have to raise your hand. If you think you have a reasonable answer, speak it out. Because, you see this box here with the grating in front? That's a secret box. Behind it is a video camera, which makes audio records as well as video records of the proceedings of this class. And I review the proceedings of this class after each and every class. And when I ask questions, I look to see who responds and who does not respond. Because if you respond, that's wonderful. If you respond incorrectly, that's okay, because at least you're participating. But if you don't respond, then I exact upon you a penalty. What shall be the first penalty for non-response? Non-participation when I ask a question. Maybe I'll ask for $20. And then I'll collect all these $20, and on a non-exam Friday night, we'll have a pizza and beer party at the expense of those of you who paid the $20. And for those of you who paid the 20 bucks, if you want to participate in the pizza and beer party, you have to pay another 20 bucks. Woo! I'm a rat. Now then, before you I have 2 flasks. All of this is discussed in the notes. They're each 500 milliliter Erlenmeyer flask. They each have deionized water and about the same volume. The difference being this flask is open to the atmosphere and this flask is closed. But deionized water is the only material contained within each flask. Shorthand reference DIW, I'm sure you recall this from your 46L laboratory manual from those of you who took 46L here, which I'm sure is most of you. In which of these flasks? Open flask, stoppered flask, closed flask. In which of these flasks can this equilibrium exist? Or is it possible that this equilibrium cannot exist in either flask? Or is it possible that this equilibrium exists in both flasks? So 4 possibilities exist. And now my video camera is on. The one that's secretly contained in there. Because I got a switch in my back pocket to keep that running. Okay? 4 possibilities. This equilibrium can exist in neither flask. Hand up if you vote yes to this. And I expect everybody to vote. This equilibrium can exist right now in both flasks. Hand up if you vote yes to this. And I don't want any votes like this. That's a half a vote. Hand up. Okay. This equilibrium exists in the open flask only. Hand up. This equilibrium exists in the closed flask only. Well. The vast majority voted correctly. Why so? Why is it that this equilibrium will not exist in this flask?
Because it'll never be constant. The gas.
What's the it? When I ask you for a response, I do not ever want to hear the word it. Carry on.
The gas will never be at a constant pressure
Why not?
because it's not closed and concealed.
Well, so why does that not allow the gas to be at constant pressure?
Because particles are always moving.
Particles are moving. Well, I agree with that. But you're leaving out an important part of this puzzle.
Because water is constantly turning into gas.
Well, let me ask this. Here in my wonderful periodic table coffee cup, I have some of this wonderful stuff, water. Now, right now, the water level's about there. If I drew a mark on my cup to indicate the meniscus level of the water, and I allow my cup to stand here on the lecture bench, open as it is, until tomorrow's class, will the water level be the same? Will the water level be higher? It's not raining in here. Will the water level be lower? Of course. Why will the water level be lower? Evaporation. Why is evaporation taking place on a net basis in this room? Tell me, if this equilibrium, water, liquid, water, vapor, if that equilibrium existed in this atmosphere we call air, if that equilibrium existed in this room right now in air, what condition from a weatherman standpoint would we be with? 100% relative humidity. Yeah. How many of you have heard 100% relative humidity? I know you've all heard of that. Now comes the hard question. How many of you understand 100% relative humidity? How many of you know what it means? What? You're in chemistry class. You don't know what 100% relative humidity means? You mean you listen to the weather people talk about this all the damn time and you don't make an effort to find out what it means? Don't do that. When, in this system called air, the air is saturated with water vapor, water in the vapor phase, it is impossible to get any more water in the vapor phase introduced into that quantity of air if it's a closed system. If that condition existed in this room right now, if 100% relative humidity existed in this room right now, would we be comfortable? Why not? Why would we not be comfortable?
We covered
Do we perspire? Yeah. Is this a natural human physiological condition? Perspiring, is that natural? We do that. Especially me, because I'm up here and jumping around like a crazy guy. Okay? Hey, if we perspire, and it's 100% relative humidity in here, there will be no longer any net evaporation of water liquid, sweat beads, from our skin surface to the atmosphere. Which means we would be gooey in our own goo. Ooh. Gooey in our own goo. How unpleasant. But because the air conditioning system in this room serves two purposes. What are the two purposes which an air conditioning system serves? Two purposes. What? What are the two purposes served by an air conditioning system if it's working properly? Two purposes.
Filter the air.
Maintain temperature.
What? Maintain temperature at which humans are comfortable. That's usually around 22, 23 centigrade. And what else? What else?
Remove moisture from the air.
Keep the relative humidity at a level at which we are comfortable, which is usually about 65 or 70%. That's about the relative humidity in here. Because if the relative humidity in here was 100%, even though the temperature would be a comfortable temperature for humans, we would be most uncomfortable because we'd be stewing in our own juices, just as I just described. So, since the air conditioning system is working, and since the relative humidity, as a consequence thereof, is less than 100%, probably around 65 or 70%, as the water liquid evaporates in this open flask, as the water liquid evaporates from my unclosed coffee cup, there is net change of water liquid to water vapor because of the operation of the air conditioning system and the existing relative humidity conditions. Which is why if in this open flask I mark the meniscus level of water, just like in my coffee cup, and we leave this open flask down on the lecture bench till tomorrow, when we come back, the water meniscus level will be lower. Might even be empty. But here, the water vapor can't go away, can it? It's trapped in there. So in this flask, we at least have the opportunity for water liquid to be in equilibrium with water vapor. And since I've had this flask standing for a good long time, I'm guaranteeing that that equilibrium condition, referred to by that equilibrium reaction equation on the board, that equilibrium condition exists in this flask. And if we were still unsure, now I know it does. Because what did I do when I shook? Did I have any impact on rates when I shook? Well, you'll think about that a little bit more. Indeed, I had an impact on rates when I shook. Now then, next question regarding this equilibrium. If I tell you to make a written expression, write an expression which states this equilibrium, what would you write? Well, the first thing you do is write a capital K. Capital K is just our chemist's symbol for an equilibrium constant. Don't get it confused with K capital for Kelvin temperature. You won't. Equilibrium constant. How do we write equilibrium constants? We write equilibrium constants as a matter of convention by including in the equilibrium constant a reference to the system components whose concentrations or partial pressures, gases, change as the equilibrium condition is established. Now, what does that mean? You're going to see all this in the notes when you get it, so you don't have to try to rush to write this down. In an equilibrium constant expression, you will see reference exclusively to system solutes, the stuffs that are dissolved in the solvent if you're dealing with a liquid system, and gases. That's it. No solids, no pure liquids. They may well be part of the equilibrium, like water liquid and water vapor, because in this flask, my coffee cup, in either flask, in any sample of water liquid, it doesn't make any difference if I got this amount of water liquid or a drop of water liquid. The concentration of water liquid in the water in the water liquid is fixed. You got an idea what the concentration is of water liquid in water liquid? Did you think about this in 2045? You know that concentrations are commonly expressed as what? Molar concentrations. What are molar concentrations? They're a ratio of moles of dissolved stuff, solute, per liter volume of solution. And that's the concentration term we're going to use in here, molar concentration. So if you are asked to define molar concentration, if you just say moles per liter, I'll give you about 30%. Because you haven't said moles of what, and you haven't said liters of what. You haven't said enough. You've got to put your definition right on the nose. Moles of solute, the dissolved stuff, per liter of solution. But when we're dealing with equilibrium systems that involve gases, it's far more convenient to deal with reference to the gases in terms of their partial pressures rather than their concentrations. Why do you think that's true? Why is it more convenient in dealing with equilibrium systems that involve gases to refer to the gas components of the equilibrium in terms of their partial pressures? This is the preferred thermodynamic way to refer to gases if they're part of an equilibrium system when you write an equilibrium constant expression for the system. Why is it better, more convenient to refer to the gas components of an equilibrium in terms of their partial pressures rather than concentrations? Why?
There's multiple variables that go into the gas state,
Tell me about these variables.
such as volume.
Well, how about volume? If I talk about the partial pressure of a gas, do I have to talk about volume? No. But if I talk about concentration, like moles per liter, then I got to talk about volume. I mean, I can express the equilibrium expression right there for this system very conveniently by writing it this way. How would I find this value? If I tell you that the water liquid in this system, or the temperature of the system itself, is the same as the temperature of the room, which is, let's take it as 23 centigrade. If I tell you the temperature of that system, the temperature of this room is 23 centigrade, what would you do right now to find the value for this equilibrium constant? What table would you look for if you had this table available? What table would you look for? Well, I'm going to give you a clue. You'll find a copy of this table in the chem notes. We'll be using it when we get to chapter 21. It's a table of vapor pressures. You all heard about vapor pressures? What is vapor pressure a measure of? You dealt with vapor pressures in 2045. Don't you know what vapor pressure is? Because if you don't know what it is, then you didn't learn a damn thing about vapor pressure. I don't care about shoving numbers into equations and pushing buttons to get an answer. I want you to understand what this means. What is vapor pressure? I don't want units. I want to know what vapor pressure means. What does it mean? What does vapor pressure mean? Who can answer for me this one?
Is it the...
Do gases have vapor pressures?
No.
Do gases have vapor pressures? How the hell can a gas have a vapor pressure? It's already a vapor. What is vapor pressure?
Tendency to evaporate.
It is a measure of the tendency of a condensed phase of material to do what? Do what?
Evaporate.
Evaporate. Convert to gas phase. All liquids and solids have vapor pressures. What physical change would I apply to a sample of a liquid or solid to change its vapor pressure?
Heat.
You just water liquid in this flask? Or the other flask, or my coffee cup? What change shall I apply to this water liquid to change its vapor pressure?
Heat it up.
Change its temperature. Heat up, cool off. Either one changes its vapor pressure. Because vapor pressure is a measure of the tendency of a solid or liquid to evaporate. So what I want to do to get this answer is to look up a table that contains vapor pressures for water liquid, specifically at the temperature 23 centigrade. Because whatever is the vapor pressure of water liquid, you see this equilibrium? It exists, doesn't it? So whatever is the vapor pressure of water liquid, it's the same as the partial pressure of water vapor. Otherwise, that condition couldn't exist, could it? And that's how I'd evaluate this. But if I want to evaluate K for this system by writing this, now I got a bigger problem. Because now I got to measure volume. I'd have to know how much water vapor is in this volume, and I'd have to know the volume. That's a lot more work than just finding this information from a table of vapor pressures. I'll just let you think about how you'd evaluate this volume if I put that task to you. Let's take a look at these systems. Let me borrow these flasks. They've served their purpose. I've got here some certified reagent grade calcium chloride. You know anything about the water solubility of calcium chloride? Do you know anything about the water solubility of calcium chloride? What do you know about it? I'm hearing a couple of murmurs which suggest that a couple of people recognize that calcium chloride is rather soluble in water. Do you have any information available, information with which you should be familiar, which supports this statement, calcium chloride is rather soluble in water? What information do you have available that supports this statement? Did you take 46 or 45 laboratory?
Yeah.
Did you pass 45 laboratory?
Yeah.
Did you do assignment 4 in 45 laboratory? In 45 laboratory, did you prepare a solution of calcium chloride by dissolving some in water? Did you prepare a solution of sodium carbonate by dissolving some in water? Because damn it, I expect you to know everything that 45 laboratory expected you to learn. How about that? I'm really a rat, aren't I? Because those are building blocks. When you're in science, just like you're in math, you're inside a giant cone of learning, a cone of knowledge. And this is a marvelous, wonderful cone because it has no top. What you discover in doing science is that the more you learn, the more you realize there is to learn. Science may well wear you out. It may well exhaust you and exacerbate you. It may frustrate the living hell out of you, but it'll never bore you. Because there is no boundary to this. The most beautiful part of science is to realize the more you learn, the more you will realize there is to learn. And that's just what we're going to do in this gathering. We'll pick it up from this point tomorrow.